Imagine for a moment that you are standing in front of a cosmic control panel. On this panel, there are dozens of unmarked dials and sliders, each one controlling a fundamental property of our universe. One dial sets the strength of gravity. Another slider determines the mass of an electron. A switch governs how strongly atomic nuclei cling together. You are told that if you were to close your eyes, reach out, and start randomly spinning these dials, the probability of creating a universe that can hold stars, planets, and life is essentially zero. Yet when we open our eyes and look at the panel that governs our reality, every single dial is set precisely to the narrow, life-permitting value. The physical constants of nature appear not merely convenient but exquisitely chosen. This, in a nutshell, is the mystery of fine-tuning. It is perhaps the most provocative and philosophically charged question in all of modern physics. For decades, it has hovered in the background of scientific discourse, an uncomfortable splinter in the mind of cosmology. We have mapped the universe. We have measured its initial expansion rate. We have weighed its particles. And everything we find points to a deeply unsettling conclusion. The fundamental laws of physics look suspiciously like they were rigged from the start. The question that naturally arises is the one we will explore today. Was the universe designed, or is there a deeper reason, a hidden principle that makes this apparent design an illusion? Let's strip this problem down to its physical roots and follow the logic wherever it leads. Because this is not a question about one number. It is a question about the nature of reality itself. Most people, when they first hear the phrase fine-tuned universe, immediately jump to a very human-centered conclusion. We are pattern-seeking creatures. We look at the improbable perfection of a sunset or the complexity of a biological cell, and our intuition screams that such order requires a designer. This is a deeply relatable everyday experience. If you are walking along a beach and find a watch lying in the sand, you don't assume the ocean and the wind assembled the gears and springs over billions of years. You infer a watchmaker. This is the classic argument from design, and it feels incredibly powerful when applied to biology or complex structures. It is easy then to carry this intuition over to physics. We look at the constants of nature. We see the numbers, and we think of them like the gears of a cosmic watch, so perfectly aligned that they must have been set by an intelligence. This intuition, however, is fundamentally misleading when we move from the complexity of arrangement to the complexity of fundamental law. Let me explain the critical difference. The watch on the beach is an arrangement of pre-existing matter. The laws of physics, the constants we are talking about, are not arrangements of matter. They are the blueprint that dictates how matter behaves. To assume a designer set the dials of gravity just shifts the question one step back, because we then must ask, what mechanism did the designer use? Where does the designer's mind reside? And what physical laws govern the structure of that designer? As a purely scientific starting point, appealing to a complex intelligence to explain a set of simple numbers is a logical non-starter. It requires us to assume a vastly more complex, unexplained entity to explain a relatively simple observation. The real reason for the dials being where they are, if there is one, must be more fundamental. It must emerge from a principle that makes these specific numbers not chosen, but inevitable. To understand why this problem keeps physicists up at night, we have to leave behind the watch metaphor and get our hands dirty with the actual dials. What exactly is being tuned? We are talking about the fundamental constants, numbers that are not derivable from any current theory, but simply measured to be what they are. Think of them as the operating system of reality. There is the strength of the gravitational force, a number so small it's almost impossible to visualize. There is the strength of the electromagnetic force, which governs light, chemistry, and the structure of atoms. There is the strong nuclear force, the glue that holds protons and neutrons together. And there are the masses of the fundamental particles, quarks, electrons, and the ghostly neutrinos. Now, here's where it gets interesting. We don't just look at these numbers and guess that they matter. We can test it. We can do a mathematical experiment in our minds and on our supercomputers. We can take the laws of physics as we know them and ask a simple question. What would happen if we changed just one of these numbers by a tiny fraction? Let's start with the force we think we know best, gravity. If you were to wave a magic wand and increase the strength of gravity by a mere tenfold, the universe would be a dramatically different place. Galaxies would still form, but they would be much denser. Stars would burn much faster and more violently. A planet like Earth might be crushed under its own weight, and any complex organism would be a squat, low-to-the-ground creature struggling against an oppressive gravitational pull. But that's still a habitable universe compared to what happens if gravity is much weaker or much stronger. If gravity were even slightly stronger compared to electromagnetism, stars would necessarily be much more massive. But there is a limit. If a star gets too massive, it burns out and explodes in a supernova in just a few million years. There is simply not enough time for planetary systems to stabilize, for life to evolve, for anything interesting to happen. If gravity were weaker, clouds of gas would never clump together densely enough to ignite nuclear fusion. You would have a cold, diffuse, dead universe of expanding hydrogen and helium, forever dark. But the fine-tuning of gravity is a crude machete compared to the surgical precision of other parameters. The most famous example, and arguably the most jaw-dropping, concerns the dark energy, or the cosmological constant. This is the energy density of empty space itself, the force that is causing the universe's expansion to accelerate. When quantum field theory attempts to calculate what this value should be, based on the vacuum fluctuations of all particles, the prediction is a number that is 120 orders of magnitude larger than what we observe. That's a 1 followed by 120 zeros. It's the worst prediction in the history of science. But set aside the theoretical failure for a moment and just focus on the observed value. If this dark energy were even slightly larger in the early universe, it would have blown the universe apart before any atoms could form. The universe would be a smooth, empty soup of isolated particles stretched into infinity. If it were negative and slightly larger, the universe would have collapsed back in on itself in a big crunch seconds after the Big Bang. We live in a universe where this pressure is unbelievably small, but precisely balanced to allow billions of years of cosmic evolution. It is as if a number was chosen from a random lottery of 10 to the power of 120 tickets, and it happened to land on the only ticket that allows you to exist. Now let's drill down to the microscopic world, to the nuclear physics that powers the sun. This is maybe the clearest example of how an entire chain of complexity rests on a knife's edge. The key player here is the strong nuclear force. This force binds quarks together into protons and neutrons. Then, a residual leakage of this force binds protons and neutrons together into atomic nuclei. The Hoyle state is a specific energy level in the carbon nucleus. Fred Hoyle, an astrophysicist who was initially skeptical of this fine-tuning, actually predicted the existence of this energy level based on the simple fact that we are here, made of carbon. Let me walk you through this logic. Stars fuse hydrogen into helium. To get to carbon, you need to fuse 3 helium nuclei together, but the chance of 3 helium nuclei hitting each other at exactly the same time is vanishingly small. The universe gets around this by doing it in 2 steps. 2 helium nuclei form beryllium, and then a 3rd helium hits the beryllium to form carbon. The problem is that beryllium is incredibly unstable. It falls apart in a fraction of a second. You have to ram that 3rd helium nucleus into it almost instantly. This only works if there is a resonant energy level in the carbon nucleus that matches the kinetic energy of the incoming helium nucleus, acting like a nuclear stepping stone that stabilizes the reaction. That's the Hoyle state. This is the key point. The energy level of carbon and the energy level of beryllium and helium are governed by the strengths of the electromagnetic and strong forces and the masses of quarks. If the strong force was shifted by just 0.5%, if the mass of the quarks were slightly different, that resonance would vanish. The stepping stone would be misplaced and the bridge to carbon would collapse. The fusion process would fizzle out and the universe would be a cold desert of hydrogen and helium. No carbon means no organic chemistry, no life, no us. The fact that the strong force is tuned to precisely this value cannot be dismissed as a coincidence without pause. It is the difference between a periodic table full of rich chemistry and the universe that never gets beyond element number 2. So far, I have described these constants as if they are just a set of numbers written on that cosmic dashboard. But to truly grasp the depth of this mystery, we need a powerful analogy. Think about pulling an old-fashioned slot machine. This isn't a slot machine with 3 wheels and a few cherries. Imagine a slot machine with dozens of wheels, and on each wheel there are millions of notches. Only one specific combination of notches pays out. In our reality, the payout is a universe with stars, heavy elements, and stable chemistry. If any single wheel is just one click off, the machine fails. You pull the lever randomly. The odds of hitting the jackpot are so astronomically low that no rational person would ever believe it happened by accident on the first pull. That's the intuition of fine-tuning. But here's a second, deeper analogy. Imagine a puddle of water lying in a pothole on a road. The puddle wakes up one morning and looks around. The puddle says, "Wow, look at this hole. It fits me perfectly. The curve of my water line matches the curve of the asphalt exactly. This hole must have been designed specifically to contain me." This is a brilliant analogy introduced by the writer Douglas Adams to illustrate a potential fallacy. The puddle fits the hole because the water adapts to the container it finds itself in. Could it be that we are the philosophical equivalent of the puddle? Our specific form of carbon-based life evolved to fit the constants of this specific universe. If the constants were different, perhaps a radically different form of life or structure or complexity would have adapted to fit that different container. This is a powerful counter-argument, but we have to be careful. The puddle analogy works perfectly for the shape of the puddle, but it fails if the hole itself is fundamentally unable to hold water. If the hole is too small, the water simply evaporates. If the hole is a sieve, the water drains away instantly. The fine-tuning argument doesn't just say that the universe is perfect for human beings. It says that if you change the constants incredibly slightly, the universe loses the ability to hold any complex structure at all. Adaptation requires a substrate. It requires time and stable matter. A universe that recollapses in a nanosecond offers no time for adaptation. A universe with only hydrogen and helium offers no solid matter to build a complex structure. A universe where dark energy rips atoms apart offers no stability. The claim is not just that the hole fits the puddle, but that the hole seems almost magically designed to be a pothole that doesn't leak. It is a very specific kind of hole among an infinite grid of useless gaps. This leads us to the point where physics and philosophy inevitably collide. When faced with the precise tuning of these dials, there are essentially three broad explanations that scientists and thinkers return to. We've alluded to the first one, the idea of a designer, a cosmic watchmaker. For many, this is a perfectly satisfying and rational conclusion. The precision of the laws implies a lawgiver, but physically, it's a conversation stopper. It puts the answer in a black box outside of physics. It's possible, but it is not a physical mechanism we can test. Let's set it aside and focus on the physical proposals. The second explanation is the one that has become the preferred escape route for many theoretical physicists, the multiverse. This is a proposal that comes in many forms. Think of cosmic inflation, the theory that our universe underwent a violent exponential expansion in its first moments. Many models of inflation are eternal. It's not a single one-time bubble. It's a process that spawns an infinite number of bubble universes, a vast cosmic foam. In each of these bubbles, as they pinch off from the mother universe, the fundamental constants might freeze out with different random values governed by some symmetry-breaking event in the early moments. If you have an infinite number of these bubbles, each a universe with its own separate physics, then the fine-tuning problem vanishes in a puff of statistical logic. Roll the dice an infinite number of times and every possible combination will occur. We naturally find ourselves in one of the vanishingly rare bubbles where the numbers happen to be right for life simply because we could not find ourselves anywhere else. This is an intoxicatingly elegant idea, often bolstered by the landscape of string theory, which suggests there are 10 to the 500 power possible sets of physical laws. In a multiverse, the cosmic dials are not finely tuned. We are just the lucky winners of a universe-wide lottery. We are the puddle in the only pothole that can hold water. But there is a literal infinity of potholes out there. But is this science? We must be intellectually honest. The multiverse in its current form is arguably not testable. These other bubbles are by definition causally disconnected from us. We cannot see them, we cannot send a signal to them, and we cannot interact with them. So is invoking an infinite ensemble of unobservable universes any more scientific than invoking a designer? Some physicists argue it's a worse violation of Occam's razor. The designer hypothesis posits one unobservable entity. The multiverse hypothesis posits an infinity of unobservable entities. Which is more extravagant? Proponents of the multiverse counter that it's not an arbitrary invention. It predicts other things, like the specific patterns in the cosmic microwave background radiation. If physics leads us step by logical step to the prediction of a multiverse, then we must take it seriously, even if we can't peek into the other rooms. Now here's where a third path emerges, the one that is perhaps the most awe-inspiring and mathematically profound. What if the puddle analogy is even deeper than we thought? What if the dials are not random, but are compelled to be where they are by a deeper, unseen layer of logic? Imagine a beautiful, intricate geometric structure, a perfect sphere. The circumference of a sphere is always necessarily a specific function of its radius, pi. You don't get to choose pi. You don't get to fine-tune p. It is an immutable outcome of geometric truth. This is what Einstein meant when he said what really interested him was whether God had any choice in the creation of the world. Could it be that the constants we measure are like pi? Could it be that they are forced into these relationships by a single, underlying, elegant mathematical structure that we haven't yet discovered? This is the hope of a theory of everything. Maybe the strength of gravity is not an arbitrary dial, but a mathematical consequence of the structure of space-time. Maybe the mass of the electron is necessarily locked to the energy scale of the quantum vacuum. If this were true, the appearance of fine-tuning is an illusion generated by our current ignorance. The universe wouldn't be designed, it would be logically inevitable. Let us conduct a thought experiment to make this idea visceral. Imagine you are a sentient character in a complex video game. You are a pioneer in a simulated world, and you decide to measure the fundamental physics of your reality. You discover that the force of gravity in your world has a specific strength, a specific number. You also discover that if that number were even a fraction of a percent different, the virtual atoms in your virtual body would fly apart. You publish a paper in your simulated scientific journal proclaiming that your game has been miraculously fine-tuned by a benevolent game designer, but then a more brilliant simulated physicist comes along. She discovers the source code of the game. She realizes that the gravity value is not an independent line of code that was hand-typed. It is a function. It is the output of a deeper algorithm, a simple equation that links gravity to the processing speed of the server and the resolution of the screen. The number couldn't be any different because it's derived from the fundamental architecture of the computer. In that moment, the illusion of design dissolves, replaced by the far deeper reality of mathematical constraint. We in our real universe are currently like those first simulated physicists. We have measured the numbers. We are shocked by their precision, but we have not yet glimpsed the source code. We don't know if there is a deeper logical constraint that removes the freedom of the dials. The search for that source code, that unified theory, is the holy grail of physics. But we have to address a common confusion that plagues this discussion. People often mistake fine-tuning for a proof that the universe is perfectly designed for life. Walk outside, breathe in. Most of the universe is a radiation-saturated, vacuum-separated, gravity-crushing hellscape. The universe is trying to kill us. It is not a cozy human-centric garden. This actually clarifies the physics. The tuning is not for teeth or eyes or human happiness. The tuning is for the existence of stable, complex structures in the first place. The tuning permits chemistry. It permits long-lived, stable stars. It permits matter to clump into galaxies. It provides a backdrop that is not too smooth and not too clumpy, not too hot and not too cold for complexity to emerge. The universe is not fine-tuned for us. We are fine-tuned by natural selection to the universe. This is the central correction to the design intuition. Biology adapts to the physics. The physics, on the other hand, seems precariously balanced to allow any biology at all. Let's return to the main question. We started with the profound sense that the cosmic dials seem impossibly precise, that the universe looks designed. Having journeyed through the heart of nuclear physics, quantum gravity, and the limits of statistical logic, what is the answer? The truthful, scientifically rigorous answer is that we do not know. But we can frame the possibilities with clarity. The fine-tuning is a real mathematical observation. It is not a hoax, and it is not a misunderstanding of the data. If you change these numbers, the universe dies. The question is, what do we do with this fact? If you are a pure empiricist, you might say the multiverse solves it. We only see this universe because only this universe can be seen. End of story. If you are a pure rationalist, you might bet on mathematical inevitability, trusting that a deeper theory will one day reveal that these constants are locked into a unique, self-consistent structure, a mathematical entity floating in the abstract space of logic, of which our physical universe is just a shadow. And if you are philosophically or spiritually inclined, you might see this precision as the fingerprint of a creative intelligence, a reason to believe that consciousness is not an accident, but a fundamental feature of a purpose-driven reality. For me, as a guide through this landscape, the most profound perspective is not about picking a side, but about recognizing what the fine-tuning reveals about our relationship with reality. It reveals that the gap between physics and philosophy is narrower than we think. The search for the origin of these constants is the search for the ultimate foundation. If the constants are an accident in a multiverse, then the foundation of reality is chaotic and fertile randomness, eternal, purposeless creation and destruction. If the constants are a mathematical necessity, then the foundation of reality is a logical, crystalline structure of perfect order, and our existence is a theorem, not a random event. And if they are set by a mind, then reality is a thought. So where does this leave us? Perhaps with a new kind of Copernican shift? We once thought our planet was the center of the universe. We were wrong. We then thought our sun was the center. We were wrong. We then thought our galaxy was the center. We were wrong. Now we are tempted to think that our specific set of physical laws, our carbon-based chemistry, is the privileged center of possibility. The fine-tuning argument suggests we might be profoundly special, living in a razor-thin sliver of habitability within the vast space of dead theoretical universes. But the ultimate lesson of the puddle might yet humble us one final time. The puddle was right that the whole was a perfect fit, but it was wrong about why. It didn't design the whole. It discovered itself to be a consequence of the whole's shape. We look out at the constants of nature and we see a universe that looks designed for complexity, but perhaps we are just a fleeting, beautiful ripple in a deep, logical, cosmic code. A code where the dials weren't set by a hand and weren't rolled by a die, but simply are what they must be. The final answer, when we find it, will not just explain the universe, it will explain our place in it. Not as the reason for the design, but as a fleeting, self-aware expression of the universe's deepest, most hidden beauty. And understanding that, truly understanding where those numbers come from, would be the final triumph of human curiosity.